Hello guys, how you doing? Welcome to Houdini, I'm Tobias, and today I'll be showing you how to rotate objects endlessly in Houdini using CHOPS with a nice fluid motion like you can see here. And don't worry about the stuttering, that's just a playback error. I'll show you how to do it nice and smooth. Now the benefits of this kind of rotation is you're not dealing with keyframes and you have a far greater degree of control over how you want the animation to play out over time, how you want it to accelerate, what's the constant RPM you want of certain objects, especially if you're working with propellers, turbines, something, car wheels, anything that rotates at a high speed and you need that rotation for extended periods of time. This is the perfect technique for you. So let's start off with something completely blank. This is your object here. It's just a normal, I think it's a PC propeller or something. PC fan. And we are going to need a transform node and a chop net. So the traditional way, or the go-to way of rotating stuff like this in Houdini would be press Alt and left mouse click to make a keyframe. Drag your timeline somewhere further away. Put in a stupid high number, keyframe again, bam. What else do you want? Well, the problem is if you're working with a minute or two, or many minutes of animation, shift control left mouse click to delete the keyframe, you are gonna get quite annoyed with the limited degree of freedom you have with this kind of technique. You can't really control the maximum speed. You can ramp it up, yes, using keyframes, blah blah, but it's not really efficient and it's not cool and you won't learn much from it. So let's do something else. Open up ChopNet. Let's jump inside and we are going to need two waveforms. One will be a sawtooth wave, and the technique is that the value increases from 0 to 360 and then drops immediately back to 0 and then goes again from 0 to 360. It ramps up and then drops back to 0 again. And we are going to need a second waveform, and this will be our ramping up or ramping down. And this will control how gradually the increase happens from 0 to 360. It basically determines the acceleration rate of our spinning object. And we are going to need a limit node and a warp node. Okay, so for our first wave, let's jump into the motion effects tab. Let's enable our display flag. And here we are going to want to play with ramps. That's it. And another thing is we'll get to the sample rate, which is very important. We'll get to that in a moment. No, actually I'll show you why. I won't even have to explain it why. And for the second wave, we don't want this sine wave, we want a constant. And we want that to gradually increase from 0 to 1. So just bring that down to 0 where it starts. And this is where our limit comes in, because this is going to ramp up into infinity. We don't want that. We want to clamp it. So let's go to, if you're pressing control and the display flag, it will unenable all display flags and only focus on that. So that's good to remember. And in here, go to clamp and minimum 0, maximum 1. Just like that. And this warp node, this will control the acceleration rate of our sawtooth or our ramp waveform. So that goes into input 1, that goes into input 2. And now we've got something like this, where it gradually increases to from 0 to 360, or in this case from 0 to 1. And then we get our constant speed right here. So we're working with degrees, and if you're working with a specific animation, I recommend you use this shift node. And what this does is you can move your waveforms left and right if you want it to start at a later time in your timeline. For example, on frame 300 you can just move this out the way. But for us, we're not going to use this, so we'll just keep that at 0. And we need a math node, because we are working with degrees, and we are going to multiply this by 360. Or actually 359.9, because 0 is 360, so we don't want two values at the same, one value and then the next value which is exactly the same. We want them to be different all the time. Now here you can see we are getting some errors in the low sample rate. We are not actually hitting the value 0 at all on any of our dips, nor we are reaching an accurate 360. We are getting close, which is good, but it's not constant. This peak is higher than this peak. It's a very noisy waveform here. We're going to have to clean that up. And our last node is export. We need to export all this into our SOP context and inform what do we want to change and where. So here the path rotate on the Z axis. We are choosing channel 1. Here we go. We have to find the right node that we're working with. /obj/chops transform 1. This is what we're working with. And let's have a look if it does something. Okay, so it is gradually accelerating. And we are getting our first problems, which is this jumpy motion. And that's because of the very low sample rate that we're using. So to get rid of that, just go back into the CHOPnet. You don't have to worry about the sample rate of this ramp, because there's nothing special about it. It's just an increase in value over time. But with this waveform, we need a quite high precision when we're working with. Like right here, you can see that what happens is our value ramps up gradually from 0 to 360 or 359.999. And then instead of jumping to 0, it jumps to a few degrees above 0. Like it goes back down gradually, and that reverses the direction of motion. Then it goes back up. So we're going up, then back down, up, back down. We don't want that. We want it to instantly smack back down. So to do that, just add, I'd say, 2 zeros, and that is looking so much better. And if we look, it actually does hit the 0 mark every time. If we get rid of them too, the precision is just crazy, and that is much healthier looking. So if we go back to our scene view, we're getting a much smoother motion, no jumpiness, no crazy glitches or anything, nice and smooth. Now, we don't want to hop into this CHOPnet all the time to make changes. We want to be able to control everything in the SOP context, just to make our life easier. So what we can do is select this CHOPnet, press this little cogwheel, and select Edit Parameter Interface. So here it's like building a HDA. We've got all the similar, we've got a similar window. Now we go into our CHOPnet, and let's select the parameters we want to control. So for our base speed, for the RPM, or the propeller, this is the period. So bring that in and drop it under root. We can call that RPM. And we also want to control the ramp slope, how fast it accelerates. So let's drop that into the root as well. And let's call it ramp. Okay, now we just press apply and accept. Let's go back here, and you can see that the parameters are now available to control outside of the CHOPnet. We don't have to jump back in. And here we can change the RPM to 2. The higher the number, the slower the RPM will be. It works in reverse. So here it's nice and slow. If we go and add 4, it's even slower. But for something lesser or smaller, it's going to get much quicker. There we go. And for the ramp, if you want a greater, slower increase, let's increase that value. Or actually the other way around, that accelerates the propeller furthermore. Or if you want a slower acceleration, there we go, nice and slow. And that will slowly reach our desired RPM value because we're using a clamp, a limit node, and that clamps it to 1 at some point. So there's nothing to worry about. And that's it. Then simple way of using chops to rotate all your rotating stuff and projects in Houdini. Hope you learned something today. It's a cool technique. I use it all the time. I highly recommend it. Chops is, I think, massively underrated. It's a very, very powerful part of Houdini. And I'll see you in the next video.